Okay, so we're just going to go through now the first type of question that you can get on heats of formation in chapter 21. So looking at the question here, we're just going to go through writing out the equations together, even though usually these first three equations we're about to write you'd be given in the question, but just as a bit of revision, we'll talk through them. So the first bit of information we're given here is that carbon dioxide has a heat of formation of minus 394 kilojoules per mole. So our heat of formation, just to revise that, is the heat change that takes place when 1 mole of a compound is formed from its elements, everything in its standard state. So we're forming carbon dioxide here, CO2, in its standard state is going to be in a gas. And we're forming it from its elements. So its elements are carbon and oxygen, and they both need to be in their standard state as well. Carbon standard state is a solid, and oxygen is going to exist as O2, and it's going to exist as a gas. So that's our heat of formation reaction for carbon dioxide. And our delta H value, they told us, is minus 394. So just to keep it as tidy as I possibly can, I'm going to not write in the units. The next bit of information that we're given is that the heat of formation of the water here is 286. I think I typed out the question wrong. That should say minus 286. So again, heat of formation of water is the formation of 1 mole of water, H2O, in its standard state. It's going to be a liquid. Remember, standard state is at 25 degrees Celsius and 101 kilopascals of pressure. And that's going to be made from its elements, hydrogen and oxygen. Both of those are going to exist as diatomic gases. So they'll be H2 and O2 gas. And then to balance our equation, we have to have 1 mole of hydrogen, of water, being produced. That's what heat of formation is. So to balance it out, we're going to have to put a half in front of the oxygen here. And the delta H value is minus 286 there. Okay, and the last bit of information that we are given is for the heat of combustion of ethanoic acid. So heat of combustion, to revise that, heat of combustion is the heat change when 1 mole of the substance is completely burned in excess oxygen. So ethanoic acid being burned completely in oxygen. So let's write the equation for that. So we're going to have CH3COOH plus, it's going to be oxygen. And we know that when we burn a hydrocarbon, our products are assumed to be carbon dioxide and water. They nearly always are, and that's all you'll be expected to know at leaving cert level. So that's ethanoic acid burning in oxygen to give carbon dioxide and water. We need to balance that equation. I have 2 carbons in ethanoic acid, so I'll need a 2 there, and I have 4 hydrogen, so I'll need a 2 in front of water as well, and that will mean to balance it out I need a 2 in front of my oxygen, and my delta H value for that is minus 876. Having a bit of trouble there. Minus 876. So they're the 3 equations that you would be given in the question normally, but I just wanted to revise because you need to be able to write them out as well. So it's a good bit of revision there, killing 2 birds with 1 stone. And then the steps I'm going to follow to go through this question are the steps outlined in the other example that you'll have to go over on page 379. So I'm going to follow the steps that they've outlined in the book there. So you've 2 examples to look at, the video and the one in the book. And step 1 is writing out the equation that you need to find. So step 1, the equation that we're being asked to calculate is calculate the heat of formation of ethanoic acid. So in the same way that we did it for the first two equations there, we're going to write out the heat of formation for ethanoic acid. So we're making ethanoic acid, CH3COOH. You can't tell that that's a tree, but it doesn't matter. And that's going to be a liquid. And that's going to be made from carbon, hydrogen, and oxygen, all in their standard states. I'll zoom in again. It doesn't look like you can see that properly. So we know we've talked about hydrogen and oxygen already, and we've talked about carbon. So that's going to be a solid, gas, and gas. So that's the overall equation that we're looking for. That's a big mess, sorry. That's the overall equation that we need to find. I might rewrite that just quickly. Bear with me 1 second. And all in their standard states, and we need to find delta H for that. So we need to balance it out. We're going to need 2 carbons, 2 hydrogen molecules, and 1 oxygen. So that's balanced now. So what we're going to do in this question is you need to rearrange and manipulate these 3 equations so that when we add everything from the left-hand side together and add everything from the right-hand side together, we get this equation down here. So we can see that we've got 2 carbons. Those carbons are going to come from here. So we need to make that into 2 carbons. We'll need hydrogens from this equation, and our ethanoic acid here is going to come from this equation. So we're going to have to rearrange those equations in order to give this equation that we've written in orange here. So I'm going to try it zoomed out again, and hopefully we can manage. Okay, so the first one I'm going to look at, so step 2 here from the book is starting to build up each reactant. So in my equation, I can see that I need 2 carbons. So from, let's call this equation A up here. Sorry, equation A. So from equation A, I'm going to have to multiply that by 2 to give me 2 carbons on the left-hand side. So that will be 2C plus, I'm not going to worry about the state symbols now, plus 2O2 going to 2CO2. So I've multiplied equation A by 2, and that's given me, in my blue box here, that's given me my 2 carbons on the left-hand side of my equation. So I've got my 2 carbons. Step 3 is going to be looking at the hydrogens. So they're next in my list. So I've got 2 hydrogens there. So what I'm going to have to do is I'm going to have to take equation B, and I'm going to have to multiply that by 2, because at the moment it only has 1 H2 molecule on the left-hand side. So that will give me 2 H2 plus O2 gives me 2 H2O. So that's equation B multiplied by 2, and it's given me my 2 H2 that I needed for my equation. Now the next step, I'm going to move on to the ethanoic acid, because for my oxygens here, you can see oxygen is involved in every single reaction down along here. So I'm going to hope that that will even itself out, that they'll all work out if I balance the rest of my equations properly, because I can't focus on any one experiment or one equation for that. So next I'm going to move on to my ethanoic acid. So equation C has ethanoic acid in it. Now we can see here ethanoic acid needs to be on the right hand side. In equation C, ethanoic acid is on the left hand side. So that means I'm going to have to flip my equation around. So at the moment this is the forward reaction. C here is the forward reaction. And for step 4 I'm going to have to reverse equation C. Reverse C. So what that means is I simply just start on the other side, with what were my reactants now become my products. So 2H2O plus 2CO2 gives me CH3COOH plus 2O2. And so now I've got my CH3COOH on the right hand side. So now my, if we were to go back here, I've got 2 carbons on the left hand side, 2 hydrogens on the left hand side of an equation, and I've got my CH3COOH, my ethanoic acid, on the right. So now what we need to do now, and what we could have done at the same time, but I just wanted to go through it separately at the moment, is we must look at what effect has this had on the delta H values. So that's what we're going to look at now. I'll stick with red for this. So the delta H value here, I multiplied my equation by 2. So my delta H value is multiplied by 2. Whatever you do to the equation, you do to the delta H value as well. So my new delta H value for A is going to be minus 394 multiplied by 2, which will give me minus 788. Minus 7, don't know why that's not working, 788. So my new delta H value is minus 788. I multiply the equation by 2, I multiply delta H by 2. Same story for equation B, I multiplied it by 2, so therefore minus 286 is going to be equal to minus 572 when I multiply it by 2. Equation multiplied by 2, delta H multiplied by 2. Now in equation C, I simply reversed it. And so I just want to do a quick little note for you over here. When we were doing regular equations, so if we were just doing A plus B gives me C, and the delta H value, let's say, was minus 178, just pulling that out of my head, we said when we were talking about Le Chatelier and all of that in equilibrium, we said that the delta H value that you're given is for the forward reaction. So here, the forward reaction has a delta H value of minus 178, the number I picked there. And what that means is for the reverse reaction, all you do is change the sign. It's plus 178. Whatever amount of energy is given out in the forward reaction is the same amount of energy that would be taken in going in the reverse reaction. So let's go back to where we were over here. And so what that means is that for C, I reversed my equation, so I also reverse my delta H value. So instead of minus 876, it's going to be plus 876. So that's all of my information now all put together. And as you might have seen just there, I've those rewritten out down here so that we can do the next part. So they're my 3 equations that I have, and what I'm trying to do is find this one that I had written in orange up here. So I might just rewrite that down here. So it's C plus H2 plus O2 gives me CH3COOH, and to balance that I need 2's there. So I need to make all of these equations equal to that. And how I'm going to do that is I am going to add up everything on the right hand side and put it in one equation, and write everything on the left hand side on the other side of the equation. So we will do that now. So I've got 2C plus 2O2 plus 2H2 plus O2 plus I've got my 2 carbon dioxides and 2 H2O. So far that is my equation when I put all 3 of these things together. So everything on the left hand side here is written on the left hand side down here. And then I need to write down my products. So I have 2 carbon dioxides plus 2 waters plus my ethanoic acid plus 2O2, 2 oxygens. So everything on the right hand side up here is written on the right hand side over here. And that's my equation. So now, as in maths, you've got some things that are on the left hand side and some things that are on the right hand side. So we're going to tidy them up. So we've got 2 carbon dioxides on the left and 2 carbon dioxides on the right. They will cancel each other out. I've got 2 waters on the left and 2 waters on the right that will cancel each other out. And I can cancel out these 2 oxygens with these 2 oxygens over here, so that my equation that I am left with then, if I was to write it out, I'm left with my 2 carbons, my hydrogen, I never wrote down the 2 there, sorry. So you can see that I just made the mistake here, I've got my 2 written up here in my equation, I just never put it in here. So my 2 hydrogens and my oxygen left on this side, and on the other side I've got CH3COOH. And if you look at that equation that I've written in black and the one that I've written in orange from the very beginning of what I needed, those 2 now should look exactly the same. The last step, the question I was asked, is to find the delta H value for that. And as you can see from the equation we wrote out, what we did was we added up all the delta H. We need to add up the delta H values here. In our equation here, we added all the equations together. So now we must add the delta H values together. So delta H for this is going to be equal to minus 788 minus 572, or you could write plus minus 572 plus 876. And so overall my delta H value for this reaction for the heat of formation of ethanoic acid is going to be minus 484, and my units are kilojoule per mole. So I'll do a separate video with the next example. Any questions on this, please go over to Teams and let me know.